At this point in our video series, we want to start talking about troubleshooting our unified communications networks. And one of the most common troubleshooting issues that's likely to come up from time to time is endpoint registration issues, where you have an IP phone, for example, that for whatever reason does not register with this call agent. It's not registering with Communications Manager or Communications Manager Express Router. Instead, it almost gets hung in a looped state. It's always trying to get an IP address or get the voice VLAN ID, or it's trying to download a configuration file, something like that. And we want to talk in this video about some common endpoint registration issues and how to check them. First of all, let's talk about CDP, Cisco Discovery Protocol, and LLDP Med. CDP, Cisco Discovery Protocol, allows adjacent Cisco devices to discover information about one another via a layer 2 connection. And if we're running CDP version 2, then we can also have an IP phone learn VLAN information. It can learn about the voice VLAN ID via CDP messages coming from the switch. That way, when the phone goes out to make a DHCP request to say, hey, I need an IP address, it's going to request an IP address as part of the appropriate subnet because it knows its voice VLAN. LLDP is an industry standard version of CDP. It has a few additional capabilities. It's a bit more flexible in many environments. LLDP stands for Link Layer Discovery Protocol, and when we tack on the MED, the MED, that means it's LLDP for media endpoint devices, which is what we have here. We've got something like a Cisco IP phone that's a media endpoint device that's using LLDP. And in a few moments, I'll take you out to the live interface and we'll see how we can configure and verify CDP and LLDP MED operation. But assuming the phone does learn its VLAN ID, it then needs to go out to a DHCP server typically, unless we hardcode this, and download information such as its IP address, its subnet mask, its default gateway, and we typically use TFTP option 150, which is going to contain the IP address of a TFTP server. After all, the phone needs to go up to this TFTP server to download its configuration file, and the DHCP server can hand out that TFTP server's IP address to our IP phone. If that's not working, then we've got some things to check when it comes to DHCP, and again, we'll do that in a live interface in just a few moments. But assuming that DHCP does say, here's your IP address, and here's your subnet mask and your default gateway and the TFTP server's IP address, if we're still not downloading our configuration file, we might need to check on the operation of the TFTP server. Is it truly serving up our configuration files? And beyond just endpoint registration referring to IP phones, keep in mind that an MGCP gateway can have different interfaces in it, and these interfaces are MGCP endpoints. And they, much like a phone, can register with Communications Manager. In fact, we can even have an MGCP gateway download an XML configuration file from a Communications Manager server, much like an IP phone would. Now let's go out to the live interface and see how we can get some more information about these potential endpoint registration troubleshooting targets. Let's begin on a Cisco Catalyst switch. I happen to be on a Cisco Catalyst 3750 series switch right now, and let's take a look at how we can verify CDP operation. We can do a show CDP command to see global information. This is confirming for me that CDP is running. I'm sending a CDP packet every 5 seconds. If I don't hear from a CDP neighbor for 3 minutes, I'm going to consider it no longer available. That's my hold time. And very important, I'm using CDP version 2. As opposed to version 1. Version 1 will not send out VLAN ID information in the advertisements. Version 2 will. We can also see who our CDP neighbors are. We'll do a show CDP neighbors, and this is going to give us a nice confirmation that these two IP phones are indeed powered up, and we see the ports to which they are attached. Excellent. And even if CDP is enabled globally, keep in mind that it could be turned off at the interface level. We might want to check the interface configuration. For example, I could go in to interface fast Ethernet 1/0/7 as an example, and I could say no CDP enable to turn off CDP for that one interface while it's still enabled globally for the other interfaces. If we're having an issue and we're not seeing something via a certain interface, let's make sure that that command is not given in that interface configuration mode. But as a real-world tip, here's typically what I do. This is a practice that I picked up while studying for my CCIE I typically go in and give these commands when I'm setting a switch up for CDP operation, just to make sure that I know that CDP is globally configured correctly. I'll do a CDP run to turn it on globally. I want to make sure my timer value which we see here is set to 5 seconds. I want to make sure that that's not some super high value, so I will typically say CDP timer 5. And also I want to make sure we're running version 2 of CDP. So I'll say CDP advertise-v2. Those are the 3 commands that I typically give as I'm about to configure a Cisco Catalyst switch to connect out to IP phones. But keep in mind, CDP, that's a Cisco proprietary protocol. Many people prefer the industry standard of LLDP med. Let's talk about that. Unlike CDP, LLDP med on this switch is not enabled by default. We can do a show LLDP and it tells us, nope, that's not enabled. So here's how we enable it if we want to use LLDP med. Let's go into global configuration mode and I'll say LLDP. Let's use some context sensitive help. And much like saying CDP run globally, I can say LLDP run globally and press enter to turn it on for all of the interfaces. Also, this is an interesting option, TLV select. LLDP TLV select. Let's use some context sensitive help to see our options. TLV, that stands for type length value. These are different fields in an LLDP advertisement that can give certain information to the connected device, like VLAN information, system name information, system capabilities information. By default, all of these type length value fields are included in the LLDP advertisements, but if we wanted to turn some off, we could. We could turn them on individually if we wanted. Just wanted to show you that option. But now that I've turned this on globally, let's go back out to global configuration mode and once again do a show LLDP, and we see that it is active. If I do a show LLDP neighbors, we can see my 2 IP phones. Those are devices that are attached to this switch that speak LLDP. And we probably want either LLDP med or CDP version 2 running, so these phones can automatically learn the VLAN ID for the voice VLAN. So now that they know what subnet, what VLAN they're a part of, they can go out to a DHCP server and make an intelligent request as to what subnet they would like an IP address from. So let's think about DHCP configuration. You can use different servers as a DHCP server. I've got this Communications Manager server set up as one. Let's check out the configuration. I've defined a server. Actually, each of my servers in my cluster can act as DHCP servers. You see the IP address, and I'm specifying here option 150. This is the IP address of a TFTP server. Now, by giving this information at the server level, as opposed to down at the subnet level, this information gets inherited by all the different subnets. So for all of the subnets, doesn't matter what subnet they are, they all will be informed about the same collection of TFTP servers. We can then go into an individual subnet. I've just got one subnet defined here, but we can go into a subnet and we can see what is the subnet's network address. And this is kind of interesting. After you give the network address up here, you've got to jump all the way down here to give the subnet mask. I always kind of thought those should be together, but they are separated. Be aware of that. You can also see the range of addresses that are going to be handed out as part of this DHCP IP address assignment. And even though we could specify DHCP option 150 here, I don't have to here because I've already specified it globally and it gets inherited down to these different subnets. So we want to make sure that all these values are correct when we're doing our troubleshooting. You might alternately have a router configured as a DHCP server. For example, router BR1 is configured as a DHCP server. Let me show you what that configuration would look like so you can better troubleshoot that. I've gone in and I've excluded some specific IP addresses. This IP address was excluded by the default configuration where it tries to do an auto config that doesn't relate to my IP phones. I put in these 2 commands. I said I wanted to exclude 10.10.140.1 all the way through 10.10.140.9. Then I wanted to exclude 10.10.140.21 all the way through 10.10.140.254. And I'm using a 24-bit subnet mask. So in other words, I'm only handing out IP addresses in the range of 10.10.140.10 through 10.10.140.20. And I've created a DHCP pool that I've given a name of IP phones. Here's the network. Here's the 24-bit subnet mask. Here's the default gateway or the default router information. And here's how I specify option 150, the IP address of my TFTP server. Let's make sure those values look correct. And something else to keep in mind with DHCP is that when a phone is trying to get IP address information via DHCP, it sends out a discover message, a DHCP discover broadcast message. Now, what happens to a broadcast when it tries to cross a router boundary? Well, by default, it gets dropped, doesn't it? Broadcasts do not propagate through routers typically, and that could leave our DHCP discover request dropped at our default router. What we can do to fix that is to specify an IP helper address. That's what I've done here on Router HQ. Let's take a look at my running configuration. I've got a sub-interface configured for my voice VLAN, my voice sub-interface, and it's gigabit 0/0.200. And when a DHCP discover message arrives on this voice VLAN's default gateway, I'm saying IP helper-address, and the helper address is the IP address of my communications manager publisher here at the HQ site. This is the server that's acting as a DHCP server for this site. So even though a discover broadcast would normally get dropped, by saying IP helper-address and specifying the IP address of your DHCP server, then that message gets relayed on to the DHCP server. There are about 9 different types of broadcast messages that get forwarded by this IP helper address command. But assuming that we've powered up, and by the way, we didn't really talk much about power, please keep in mind that you can have power over Ethernet configured on your Cisco Catalyst switch. You can do a show power inline to see the current status, and you can say power inline never or power inline auto to configure power over Ethernet for one of your switch ports. But assuming that we have power and CDP or LLDP Med has told us what subnet we're a member of, and assuming that we've gone out and we've got an IP address for that subnet, now it's time for the phone to reach up to a TFTP server and download its configuration file. Let's see what might go wrong there. Well, one of the big things that we check when we're troubleshooting DHCP is what we've already seen. We want to make sure that DHCP is handing out the appropriate IP address of a TFTP server. But something else we might want to check is we might want to verify that the TFTP service is running on that server. Let's go under Navigation and go into Cisco Unified Serviceability, and let's verify that TFTP is indeed running on this server. It's a separate service from Communications Manager. Let's go under Tools, Control Center Feature Services, and let's go into my publisher first of all. And let's scroll down just a bit and confirm that Cisco TFTP is indeed started and activated. It is fantastic. We can check out our subscriber as well, because we might be going out and downloading a configuration file from a subscriber, and it looks like we're started and activated for our subscriber server as well. Now, the final thing we want to talk about in relation to endpoint registration is MGCP gateway registration. You see, it's not just IP phones that register with Communications Manager, it's an MGCP gateway. And an MGCP gateway, that's the router, and the router can contain multiple MGCP endpoints. An endpoint is a specific voice port that's installed inside of the router, inside of the gateway. And here in my topology, I've got router BR1 configured as an MGCP gateway. Here's probably my favorite command for troubleshooting MGCP. That command is show CCM-manager. And we can see that this gateway is registered with this server. And if this server goes down, because I'm assigned a communications manager group just like an IP phone, I've got this secondary communications manager server ready to step in. So things look good here. I am indeed registered, but let's say that I'm not registered for some reason. Well, we can go through and double check our configuration. You can look at most of your MGCP commands on the router by doing a show run pipe to include MGCP, or that's another vertical pipe, CCM-manager. And we can see the collection of commands that make this an MGCP gateway. And we see that this is our primary call agent, this is our backup call agent. Things are looking pretty good here. We could also verify that our gateway is registered by going into our Communications Manager server and going under Device, Gateway. We'll do a find. And for this MGCP gateway that we've got defined, I can say, show me the endpoints. And it tells me that the status is registered. So that's good news. What if we're not registered, however? Well, let's take a look at some common misconfigurations. One thing we need to check is the endpoint name. Notice the structure of this name. This is slot 0, referring to the motherboard. The motherboard has a controller on it, which controls, on this particular model of router, a Cisco 2911, it controls these 4 voice WAN interface card slots. Now I'm in subunit 0, which is the first of those slots, and I'm using DS1 0. In other words, the T1 port is the first port. The numbering starts at 0. My controller, in other words, is 0/0/0. And we can verify that that is indeed the correct endpoint. I can go to my router and do a show inventory to make sure that I'm pointing to the correct endpoint. And here's my voice WAN interface card. It's version 2, VWIC 2, 2 MFT, 2 multiplex trunks, meaning it's got 2 ports on it. And these ports can be configured either as E1 or T1 ports. I'm configured as a T1 port. And you see it's slot 0, sub-slot 0. And since we start the numbering at 0, the port number is 0. That would be 0/0/0. So that looks good. What about this, though? We're saying that we've got this endpoint at br1.kwtrain.com. Let me show you where this comes from. Let's say that I'm adding a brand new MGCP gateway. Let's say that I want to add an MGCP gateway for a Cisco 2911. We'll say next. The name of my router, the host name, is BR1. However, BR1 by itself is not enough in this case, because if I have a domain name configured on this router, then I need to specify the full domain name. I can check. I'll do a show run pipe to include domain. Do I have any domain commands here? Yeah, I am setting the domain name, you can see, to kwtrain.com. In fact, remember that show CCM-manager command we saw earlier? It tells us very clearly that the MGCP domain name is br1.kwtrain.com. So since I am statically configuring a domain name, I need to include this full name as the gateway's name. If I did not have this command to set the domain name, then I would just specify the router's host name. I would just say br1. However, in this case, I would need to say br1.kwtrain.com. That's a mistake that's really easy to make, so please be careful of that one. So those are some of the common things to keep in mind when you're troubleshooting endpoint registration. You want to make sure that the phone is, first of all, powered up. You can troubleshoot power, but assuming that it has power, you want to make sure that it's getting VLAN information so it knows its subnet. Once it knows its subnet, and it can learn that via CDP version 2 or LLDP med, you want to make sure that it goes out and gets an IP address, a subnet mask, a default gateway, and probably D8CP option 150, which specifies the TFTP server. We might want to make sure the TFTP server is indeed running on the call agent to make sure that we can download our configuration file. And it's not just IP phones that need to register, it's also MGCP gateways.